In this video, we're going to be looking at circles and circle equations. Okay, so you should know from GCSE that this is the equation of a circle. X squared plus y squared equals 9. And I've drawn what the circle would look like on the left. So from the circle I've drawn on the left, you can see that the radius is 3. And so generally, it's always x squared plus y squared equals the radius squared, 3 squared. Okay, another thing you should have noticed is that this circle has the center, the origin, 0, 0. And whenever you have x squared plus y squared, that's going to be the case. It's going to have a center 0, 0. And in GCSE, that was fine. But in A level, we're going to have to look at circles with different centers, not just the origin. So here I've got a circle with the center 3, 5. Now, what's the equation going to be? We do know the equation always equals to the radius squared, as before. And here, you should be able to see what the radius is. And we can look at this and say the radius is definitely 3. So we know the equation is going to equate to 3 squared. But what's the rest of the equation? And I'm going to show you that now. Rather than x squared, it's going to be x minus the x coordinate of the center squared. So the x coordinate of the center is 3. So it's going to be x minus 3 squared. And the same thing goes for y. Instead of y squared as before, it's going to be y minus the y coordinate of the center squared. And the y coordinate of the center is 5. So it's going to be y minus 5 squared. And this bit we've already worked out is always equal to the radius squared. And the radius squared, and the radius is 3, so the radius squared is 9. Some people just write 3 squared here, but 9 is fine. So here's the general equation of a circle with a center A, B, and the radius R. So this is the general format of equation of a circle, which you should know and memorize. Okay, so take a moment to memorize this, and we're going to practice a few questions. Now here we've got equation of a circle, but it's not in the form we like. So it's very difficult to see what the center is, and it's very difficult to see what the radius is. However, we can get it into the form we like with a simple few steps. And it's going to involve completing the square. Not once, but twice. Okay, so let's start this off. I'm going to start off by writing the x's next to each other and the y's next to each other. Okay, so you should be familiar with completing the square. So let's go ahead and do that. So we've got 8x here, so we're going to write x plus 4 squared. Now there's going to be extra 16 because of the 4 squared, so we subtract 16. We've got a minus 4 in front of the y, so we're going to half that, that's minus 2. So we'll write here y minus 2 squared. And that gives us an extra plus 4. So we'll minus 4 to get rid of that. And that's equal to 6. Now those extra numbers we've got here, minus 16 and minus 4, we'll throw it to the other side. And now we're happy, we got it in the form we like. And we can see what the center is and what the radius is. Now you should be able to say what the center is. And hopefully you said minus 4, 2. And the radius is root 26. I've kept the general equation of a circle up there on the left. Now we need to find the equation of the circle with a center 4, 9 and radius 2. So let's go ahead and do that. So it's going to be x minus the x coordinate of the center plus y minus the y coordinate of the center. And it's always squared. And it equals to the radius squared. So the radius is 2. It's going to equal to 4. Okay, let's do another one. So it's going to be x minus x coordinate squared. However, the x coordinate here is minus 2. So you just need to be a little bit careful. It's going to be minus 2, which becomes plus 2. And the same thing goes for y. It's going to be y minus the y coordinate of the center squared. And that equals to the radius squared. And the radius squared here again is 2. So it's going to be 4. Okay, one last one. I'll give you a moment to have a go yourself. And you should have said x minus 1 squared. And that's going to be y minus 1. So it's going to be y plus 1. And it equals to, we can say 7 squared or 49. Okay, now we need to find the radius at the center of the circles with the following equations. Okay, the first one is perfectly in the format of the general equation. And you can see that a must be 2 and b must be 4. So the center is 2, 4. And it's equal to 16. And remember, it's equal to the radius squared. So the radius must be 4. And the next one, now it's not quite in the format because we have a plus 4 there. So that means b must have been minus 4 to make it a plus 4. So the center will be 3 minus 4. And you just have to be careful with those ones. And it's equal to 2 squared. So the radius must be 2 here. And pause the video and have a go at the last one. There we have the center. And you should have got the radius as root 10. Because remember, it equals to the radius squared. Hence the radius must be root 10. Now for circle equations, it's really important to remember some of your circle theorems. Now all of the theorems don't come into play in the AS chapter of circles. But some of them come up a lot. And I'll put a few of them here now. Okay, so looking at A, you should remember this. That angles in a semicircle is always 90. And on B, we have a perpendicular line. And that perpendicular line is always going to be a bisector here. And in C, if you have two tangents coming from the same point, these tangents will always be the same length. And in D, a very common one, a radius and a tangent always meet at 90 degrees. Okay, let's have a look at this question here. Now it wants us to work out the length PQ. It's given us the equation of the circle, so we know the center and we know the radius, and we need to work out this length of this PQ. So I'll let you have a moment to have a go at this question. Okay, the first step. So you need to draw on the radius. And we know from our rule that this is a 90 degrees angle. The next thing I'll do is join up O and Q. And brilliant, we have a nice right angle triangle. Okay, we know one of the lengths of the triangle. From the equation of the circle, you can see that the radius must be 4. And we can work out the other length, the distance OQ, because we've got both points. Now, if you didn't know the distance between 2 points, I'm going to show you the equation for it now. So it's x2 minus x1 squared plus y2 minus y1 squared, all square rooted. So we're going to have 10 minus 4, which is 6 squared, plus 10 minus 6, which is 4 squared. And that gives us root 52. So you've got two lengths on your right angle triangle, and you should be able to say that we can do Pythagoras to work out that last length. And we get PQ equals 6. Okay, so let's look at this last example. Here we've got a circle and 3 points are given, and we ought to work out the equation of this circle. Now there's an extra piece of information which makes this question a little bit easier. Otherwise, this is a very tough question. The fact that AB is the diameter of a circle makes it much easier for us, because it allows us to work out the center of that circle right away, as the midpoint of the diameter must be the center. So we can simply work out the midpoint of these 2 points. And we do that by taking the mean of the x values and the mean of the y values. So we have minus 8 plus 4, which gives us minus 4, divided by 2, that gives us minus 2. Then we have 1 plus 5, which is 6, divided by 2 gives us 3. So we've got the center of our circle. Now, to work out the radius, which is the other thing we need to get the equation of the circle, we can either work out the distance between A and B and half it, or just simply work out the distance between the center and A. or the center and any of the 3 points on the circle. I'm going to work out the distance between A and B and just half it, because I know the points I'll be using were given by the question and they're definitely correct. And remember what we worked out is the distance between A and B. So that's the length of the diameter. We need to half this to get the radius. So we can simply now write the equation of this circle. It's going to be x minus the x coordinate, which is minus 2 as well, and that ends up being plus 2. And it's going to be y minus the y coordinate. Now it's going to be equal to the square of the radius, and that's going to be 40. So this question wasn't that bad. And notice we didn't even need to use that point C. So if you know 2 points are the diameter, even those 2 points are enough to work out the equation of the circle. Now just before you go, I'm going to just talk to you about one other type of question, which can be really tricky. If you're given a question where you're given 3 random points on a circle, and no 2 points make up the diameter, and you ought to work out the equation of that circle. Now that's a very tricky question, and it'll probably be a 6 or a 7 marker. Okay, so how would you do that? Now I've made 2 chords using the points. What you're going to do is work out the perpendicular bisector of each chord. So the way you can do that is work out the gradient between the 2 points, and the perpendicular bisector, of course, it will be the negative reciprocal. So for this perpendicular bisector I've drawn out here, we can get the gradient of it. Like I mentioned, you'd get the gradient of the 2 points and then use the negative reciprocal of that as it's perpendicular. However, you need one more piece of information. You need to know a point for this perpendicular bisector. And of course, it goes through the midpoint of those 2 points on the chord. And working at the midpoint will be very easy. So then you'll have all the information you need to work out the equation of this perpendicular bisector. And you'll do exactly the same for the other chord. Now, once you've worked out the equation of those 2 perpendicular bisectors, the really cool thing is these perpendicular bisectors meet at the center of the circle. So you can do simultaneous equations with the 2 equations, and that will give you the center of the circle. That's this point here. Now, once you've got the center of the circle, you can do the distance between that point and any of the other points to work out the radius. And then you have all the information you need to work out the equation of that circle. So this is a really tricky question if they do ask that. I just thought I'll show you. And there you have it. I hope you found that video useful. Support us by liking, subscribing, and share this with your friends. And if you still got some more questions on anything, drop a post on our forum at examqa.com where you'll find your questions answered.